So what I'm going to do in this video here is show you how to solve for the equivalent resistance and maybe some other values in a series circuit and then in a parallel circuit. A series circuit, just as a refresher, is defined as a circuit that has one continuous loop. You can think of it as if you took your voltage source, in this case a battery, cut it in half, you had the positive end here, and then you stretched it out in a string, like a straight line, so to speak, with the schematic. As you pass through one element to another, in our case we have 4 resistors. This should be R4 here, I see. As you pass through 4 resistors, you would notice that, we'll call it R4, the current would have to go through each one in order to get to the other end of the circuit, to the other side of the voltage source, or the battery in this case. So that's what defines a series circuit. We can use Ohm's law to do some calculating of some values. So let's go ahead and start with what we know about the picture. And if you take a look, we know the battery's voltage source, as indicated by the picture, is 15 volts. We have 4 resistors, R1, R2, R3, and R4, which have resistances of 15 kiloohms, 2.2 kiloohms, 10 kiloohms, and 4.7 kiloohms, respectively. And then a current would then logically flow through the circuit, an electrical current, but we don't know what that is because we're not given it. And if this were a real circuit and it was constructed to these specifications, we could take a few readings using our voltmeter. If we had to figure out the current, we would put the DMM, digital multimeter, in series with the circuit, measure the current flow through the circuit, and have that value. But more often than not, when you analyze circuits, and I might make a separate video on this later on showing you techniques, but when you analyze a circuit to troubleshoot it, if you can figure out the resistance, or rather if you know the voltage drop across a resistive element and you know the source voltage for that particular loop in the circuit or the circuit in general, you can figure out almost anything else. Okay, but that's a story for another day. So here's what we're going to do. We're going to find, we'll keep it simple, 2 things. Okay, we're going to find the equivalent resistance of the circuit, which is, well, what is the total resistance that this battery is going to be put across as the current travels through it. And then we will identify or mathematically determine, using Ohm's law, the current in the circuit. Because if we know the current in the circuit and we know the equivalent resistance, or if we know the current in the circuit and we know the resistance through which that current is passing, we can calculate the voltage drop across each element, and the sum of the voltage drops should equal the source voltage in the most ideal world. So for a series circuit, you need to understand a few things. For a series circuit, all resistive elements, or all elements, resistors and other things, all elements in the circuit see the same current. Meaning, if you envision this to be like maybe a pipe with water in it, there's a certain amount of water flowing through this pipe at all amount of times, on the assumption that the pressure, maybe the fire hydrant, whatever, is outputting a constant pressure. So if there were maybe 10 psi of water here, we would expect and hope to find it at each of these little points, resistors, as it makes its way through the exit. Okay, but this is a circuit, so let's talk about it in terms of things. In order to find the equivalent resistance in a series circuit, you simply add up all the resistances. Well, we have the 15 kiloohm, we have the 2.2 kiloohm, we have a 10 kiloohm, and we have the 4.7 kiloohm. And rather than putting us in jeopardy from a simple mistake, we'll just add all these up. And I end up with 31.9 kiloohms. Okay, that right there is the equivalent resistance. more often expressed as REQ, okay? R with little EQ, so rewriting that, 31, that's terrible, 31.9 kilo ohms, that's the equivalent resistance. To figure out the total voltage, the total resistance, let's try this again. In order to find the total current in a series circuit, you take the total voltage divided by the total resistance. This comes from Ohm's law, V equals IR. Sometimes you will see it as delta V, meaning change in voltage, but what I'm telling you is consistent throughout. So if I want to isolate the I, the current, well, current is delta V over R, just by rearranging. Our source voltage, 15 volts. I will leave units off for the sake of just leaving units off. Over 31.9 kilo ohms. I have to write the K because that's a scientific prefix which implies 1000. So if I take 15 volts divided by 31.9 to the third power, or let me show you how I've written this out so there is no confusion, 31900, we end up with 4.7 times 10 to the minus 4 amps, okay? The unit of electrical current is amperes, which you could write this in a couple different ways. You could write the value certainly as that. You could also write as 470 microamps, not very large. Also 0.47 milliamps, okay? Scientific prefix, it is what it is. Pick your poison, doesn't matter. They all mean the same thing. That being said, if I wanted to figure out the voltage dropped, for example, maybe across the 15 kilo ohm resistor, so if I call this, since that's R1, I'll call it V1. If I want to find the voltage dropped across, I would use this. It's a series circuit. All resistive elements see the same current, so I go ahead and enter it like such, times 15 times 10 to the third power. And in going through this calculation in very quick order, I end up with 7.05 volts. So of the total 15, not quite half is dropped across that 15 kilo ohm resistor. Makes sense, since it is one of the larger resistance values, but it's not quite half. We could go through the same process and we would find that the sum of all the voltages across each of these resistors would add up to the 15 that we were started. You could also do, you might think about this in terms of a proportion, so here's a quick way to do it. So the voltage across, in this case I'll call it resistive element 1, is the total voltage multiplied by that resistor over the equivalent resistance. Okay, it's dropped over that resistor as a proportion of the total voltage present, and they call this equation that I had just expressed right here a voltage divider equation, and as it's expressed in this series circuit, that is a suitable way to go about handling this. So we'll go ahead and leave it at this, and I'll show you folks in another video here how to do the same thing with a parallel circuit.